Okay, hello Cloud Gurus and welcome to this section of the course. In this section, we're going to learn about VPCs, and in this lecture, I'm going to give you a high-level overview. Basically, obviously, knowing VPCs inside out was essential for you passing one of your associate exams. You probably do know all this stuff already. However, for some of you, that might have been 18 months ago and you don't use VPCs, in your day-to-day jobs. So maybe you need a little bit of a refresher. I'll go through this fairly quickly and then we'll be able to move on. It is a very important part of the security exam. So in this section, we're going to build out our own VPC. We're going to use public and private subnets. At the end, you'll see a VPC cleanup lecture. I'd only do that if you have no plans on going in and provisioning a cloud HSM, which we do in the next section. If you are going to provision a cloud HSM, please leave your VPC as it is and then go in and delete it after the cloud HSM section. Like I keep saying, cloud HSM is only worth a couple of marks on the exam, but understanding it inside out is essential if you want to work as a security analyst in the AWS space. So that section is completely optional. It's up to you whether or not you want to do it. So what is a VPC? I think we all know what a VPC is, but it's a virtual data center in the cloud. Amazon's definition is that it lets you provision a logical, isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selecting your own IP addresses, creation of your own subnets, configuration of your own route tables, and network gateways. You can easily customize the network configuration for your VPC. For example, you can create public-facing subnets for your web servers and that have access to the internet, and place your backend systems such as databases or application servers in a private-facing subnet with no internet access. And that's exactly what we're going to do with our cloud HSM devices. And you can then leverage multiple layers of security, including security groups, network access control lists or NACLs, to help you control access to your EC2 instances in each subnet. Additionally, you can create a hardware VPN network connection between your corporate data center and your VPC and leverage the AWS cloud as an existing extension of your corporate data center. So what does a VPC look like? Well, let's go through the fundamental components. So we've got our red line, which is essentially our region. This is in US East 1. Then got our VPC called A Cloud Guru. It's got this network address range, so 10.0.0.0/16. This is the largest network address range that Amazon allow, and the smallest is a /28. So we then have our access into our VPC environment. This is either via an internet gateway or virtual private gateway. Virtual private gateways we use to connect VPNs. Internet gateways is what we use to connect our internet. Essentially, this will go through and hit a router or router, depending on where you're from, and then we go through and we configure how this traffic is routed or routed via our route or route tables. I'm not going to keep saying that over and over again. I'm just going to continue saying route tables because that's what I call them. So we then have our traffic hitting our network access control list. If you remember from the associate level courses that these are stateless. So if you're opening up port 80, you have to do that both inbound and outbound in order for it to work. Whereas with security groups, when we open it up, it opens up both inbound and outbound ports automatically. So security groups are stateful. So traffic goes through our network ACLs. This is basically our first line of defense. It then hits our security groups, and then our security groups govern whether or not that traffic is allowed to talk to our instances, and we do that by setting up rules. In here, we've got a public subnet, so it's 10.0.1.0, and it's a /24. In here, we've got a private, so it's 10.0.2.0 and it's /24, etc., etc. Now, I want to show you a really cool website that I use. I'm not a strong networking guy. I used to hate subnetting when I was doing my Cisco certs, but I love this site. So this site's called CIDR, CIDR.xyz. And in here, it allows you to basically enter in your address ranges and then visually depict them and give you a whole bunch of information. So the smallest subnet that you can get is a /28 inside a VPC. That will give you 16 IP addresses, the first IP address being 10.0.0.1 and the last one being 10.0.0.14. And then, of course, the largest is a /16. So that will give us 65,536 addresses, the first being 10.0.0.1, the last being 10.0.255.254. So this is really good for planning out your VPCs. Don't worry if you need more than 65,536 IP addresses. You can have multiple VPCs inside a region, and there's a soft limit of 5 per region, but you can always get that increased. So you can have multiple VPCs inside a region as well. I'm sure you already know that. So what can you do with a VPC? Well, obviously you can launch instances into a subnet of your choosing. You can assign custom IP address ranges for each subnet. You can configure route tables between your subnets. You can create internet gateways and attach them to our VPCs. And you get much better security control over your AWS resources. So you get instance security groups, and then you get subnet network access control lists, which we're going to play around with in quite a bit of detail coming up. In terms of our default VPC versus our custom VPC, what are the differences? Well, our default VPC is user-friendly. It's created automatically in every region around the world when we first create our AWS account. It allows you to immediately deploy instances in it. We've been using the default VPC for all of this course so far. All subnets in default VPC have a route out to the internet, and that's basically why I've been holding off and teaching you guys Cloud HSM, because we really want our Cloud HSM to be in private subnets. We really don't want people to have internet accessibility to HSM because it's such a key critical piece of infrastructure. We also know that each EC2 instance has both a public and private address in a default VPC. If we're deploying them into custom VPCs, they obviously will not have public IP addresses if they are going into private subnet. Moving on to peering, as you all know, I got to use my detective icon again. You can peer VPCs with each other, so you can connect one VPC with another via a direct network route and using a public IP address. Instances behave as if they were on the same private network, and you can even peer VPCs with other AWS accounts, as well as other VPCs in the same account. And then peering is in a star configuration, so you always have one central VPC paired with 4 others. You will not have transitive peering. So what do we mean by that? Well, if we have VPC A is able to talk to VPC B and VPC C, as well as VPC D and E. But if we have EC2 instances in VPC B and we want them to talk to VPC C, they can't do that via VPC A. So there's no transitive peering. What we have to do is we have to create a peering between VPC B and VPC C, and then they'll be able to go in and talk to each other. So moving on to just my exam tips. Again, this is all very high level at this stage. I'm just reminding you of what you already know from passing your associate exams. So think of a VPC as a logical data center in AWS. It consists of internet gateways or virtual private gateways, route tables, network access control lists, subnets, and security groups. One subnet equals one availability zone. That's always key to remember. And then security groups are stateful, network access control lists are stateless. What do we mean by that? If I go in and open port 80 on my security group, that automatically opens both inbound and outbound ports. If I do it on network access control list, I have to open the port up both inbound and outbound, so it's stateless. So that's just really important to remember. They probably will test you on that in the exam. And again, remember that there's no transitive peering. Okay, that is it. The theory is done. So again, you probably know how to build out your VPC already. If so, you could probably skip the next lecture, but I'm going to just dive in just in case people want some reminding. So we're going to go out and build a VPC. We're probably going to do this in Northern Virginia. We want to build our VPCs in a region that supports Cloud HSM, because if you build out your custom VPC in a region that doesn't support Cloud HSM, you won't be able to do the Cloud HSM part of this course. So go ahead and just type into Google what regions are currently supported by Cloud HSM, and there should, right now there's 4, but I'm sure there's going to be many, many more in the next 12 months. So choose a region that will suit. I'm going to do mine in Northern Virginia, so you might want to do the same. So that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.